Okay, hi Mathies. It is Michelle here, and we've got another 7th grade SBAC style question, and this one's a little bit of a doozy. So let's take a look. It says select all the tables that represent a proportional relationship between X and Y. The reason why this is a doozy is because it says all. In a previous video, we weren't asked to select all. We were just asked to select the one table. Because it says select all, we literally have to check every single one of them to see if they're proportional relationships. Now, typically speaking, when you actually take the SBAC, you will see boxes, which you'll check, okay? In this case, we're not gonna, you clearly aren't gonna be doing the checks, but you get the point. But let's double check. Two things about proportional relationships. Remember, number one, they have to start at 0, 0. So if any one of these did not start at 0, 0, it wouldn't be proportional. We would exit out right away. Unfortunately, they tried to trick us, and every single one of them starts at 0, 0, so we still have to test every single one of them. The next thing is proportions have to have a unit rate or a scale factor that continually goes up that same value. So if I do 1, my scale factor is 2, my next one will be 2. Well, you wouldn't start at 1, but like if you start at 1, 2, the next one's going to be 2, 4, because you multiply by the same number, okay? So the scale factor for all the numbers have to be the same. Now there's two ways to do it. One way to do it is to do it algebraically, which I'll show you for all of them. Another way, which I'm only going to show you for number 1, is to plot the points, okay? So let's look, or letter A, to plot the points. 0, 0, so we got that, check. Okay, 1 times what number will give us 4? The other thing you can think about is 4 divided by what number gives us 1. It doesn't matter. I like to do multiplication. I know that 1 times 4 is 4. So then I'm going to check here. Well, 2 times what number gives us 8? 2 times 4 gives us 8. And 3 times what number gives us 12? 3 times 4. So because it starts at 0, 0, at each one of those points, the x values increases by 4, I know that this indeed is a proportion. Now, the other way you can do it, if you don't remember what a proportional relationship is, you might remember it starts at 0, 0 and it's a straight line. That might be something else that you might think of. So if I just do a sketch, 9, 10, 11, 12, 1, 2, 3, 4. Here's my, oh, that's not correct. Over 1 up 4, over 2 up 8, 1, 2, 3, 4, 5, 6, 7, 8. And then this one goes to here. This is a sketch. I don't know when my dots are going cray-cray, but you can use your imagination that indeed it is a straight line, so it would be a proportion. Either way is fine. Okay, this one kind of is a bummeroo. 2 to 3 is actually, we'd have to multiply by 1.5. Okay. 4 to 5, we would actually multiply by 1.25. Now, if you don't know how to do that, watch this. 2, I don't know why I keep having that go. I'm sorry, guys. Let's see. 2 goes into 3. 2 goes into 3 one time. 2, 1, 0, 0, decimal point 5. That's how I did that. Okay. If I test for the next one, I can see how many times does 4 go into 5. 4 goes into 5 once. Bring down a 0. 4 goes into 2 times. 10. 2 times 4 is 8. I know I'm going fast. You probably would have a calculator for this one, but just in case you don't, I'll show you. So that's how I know. Now, I don't even have to do 6 and 7 because I already know that these numbers aren't the same. 1.5 is the same as 1.25. So I know it's not number or letter B. All right, now this one, remember, it has to be the same multiplying or dividing across the factors. So here, to get from 8 to 4, I divide by 2. To get from 12 to 6, I divide by 2. And to get from 16 to 8, I divide by 2. Now, if you've had me as a teacher, I've told you that there's no such thing as division. It's really multiplying by a fraction. So in this case, it really is multiplying by 1/2. So because of that, even though it's decreasing, it is indeed a proportional relationship. All right, let's look at the last one. 5 to 10, we multiply by 2. 10 to 20, we multiply by 2. 15 to 30, we multiply by 2. So indeed, this one is also a proportional relationship. Okay, just a refresher. They always have to start at 0, 0. So if this was like, for example, 1, 1, it wouldn't be proportional because it starts at 1, 1 and not at 0, 0. If it was like 0, 4, would not be proportional because it doesn't start at 0, 0. So make sure they start at 0, 0. Next, you're going to figure out how much they increase and decrease. And if they consistently increase by the same value or they consistently decrease by division by the same value, then you know it's a proportional relationship. If you don't remember that information, just graph it. If it's a straight line, it's proportional. All right, Mathies, that's it for now. I'll catch you all later. Ciao.